Bismillahirrahmanirrahim. Assalamu alaikum students. Here is Mubashir Riaz. Today we are going to start our chapter number 5, turning effect of forces, and the first topic is moment of force. So in this topic we'll discuss about the turning effect of force. How force can rotate an object about a fixed point. So what is meant by the moment of force? Moment of force is the turning effect of force which is produced in an object about an axis of rotation. कि जब आप एक ऑब्जेक्ट पर फोर्स अप्लाई करें और उससे वो ऑब्जेक्ट एक फिक्स पॉइंट के अबाउट एक एक्सिस ऑफ रोटेशन के अबाउट रोटेट हो, उसमें टर्निंग इफेक्ट प्रोड्यूस हो, so this effect of force is called moment of force. So in routine life we can observe the turning effect of force in different objects. For example, in case of house door, so when we apply force at its one end, it tends to rotate about its own axis of rotation. इसमें आप एक turning effect note कर पाएंगे. So this is called the moment of force. Similarly, in case of a steering wheel, so when we apply force on the steering wheel, it tends to rotate. And the similar effect can also be observed in case of spanner while tightening or loosening a nut. So with the help of these examples, we can describe this moment of force. Moment of force is actually the product of force and moment arm. It is product of force and moment arm. So here moment of force is equal to force multiplied by moment arm. Force is represented by F and moment arm is represented by D. So this product is called moment of force. For example, that there is a rod and this rod is fixed from its one end, and this end acts as a pivot point or axis of rotation, and a force F is applied at this point. Here red dotted line is actually the line of action of force. This is the line of action of force where force is being applied, and the distance between the axis of rotation and the line of action of force, this is called moment arm, represented by D. So when a force is applied at this point perpendicular to its moment arm, this angle should be 90 degree. When it is perpendicular to the moment arm, then this object tends to rotate. आप नोट करेंगे कि ये रॉड इस एक्सिस ऑफ रोटेशन के अबाउट घूमना शुरू कर देगा, इसमें टर्निंग इफेक्ट प्रोड्यूस होगा. So this turning effect of force is actually called the moment of force, which is product of applied force and the moment arm. So moment arm can be defined as the perpendicular distance from the axis of rotation to the line of action of force. यानी axis of rotation से लेकर इस point से लेकर इस line तक ये जो दरमियान में gap है, this is called moment arm and it is represented by D. Torque depends upon moment of force is also called torque. So moment of force or torque depends upon these two factors. Number one is the applied force. If applied force is greater, then greater turning effect will produce. If applied force is smaller, then smaller turning effect can be observed. As you can see in this pic, there is a larger force, greater weight, and greater turning effect. Less weight, less turning effect. So with greater applied force, moment of force is also greater. And the second factor is the moment arm. So if moment arm is greater, then turning effect is also greater. And if moment arm is smaller, then turning effect is also smaller. So with respect to these two quantities, moment of force depends upon these two factors, and they are directly proportional to each other. Applied force is greater, turning effect is also greater. Moment arm is greater, then turning effect is also greater. So torque depends upon these two factors. There is a very important point. If line of action of force passes through the pivot point, passes through the axis of rotation, then no turning effect will produce. जैसा कि यहाँ ये एक example है कि again by considering the same rod which is fixed from this end, which acts as its pivot point or axis of rotation. So if line of action of force, this dotted line is the line of action of force, यानी वो line जिसके along आप force apply कर रहे हो. So if line of action of force is passing through the pivot point से अगर pass हो रही हो, then turning effect will not produce. Torque produce नहीं होगा, moment of force produce नहीं होगा, because in such case moment arm becomes zero, because moment arm is actually a perpendicular distance. तो यहाँ इस केस में मोमेंट आर्म जीरो हो जाएगा. So if moment arm becomes zero, then moment of force is also zero. There are two types of moments: clockwise moment and anti-clockwise moment. Anti-clockwise moment is also called counterclockwise moment. So these are two types of moments. For example, in this diagram, in this picture, there are two forces, 300 Newton and 450 Newton. 300 Newton is the weight of girl, 450 Newton is the weight of boy, and 300 Newton is producing a clockwise moment, and 450 Newton is producing anti-clockwise moment. यानी जिस तरह घड़ी की needles rotate होती हैं, that is clockwise moment, और उसके जो opposite होगा, that is anti-clockwise moment. So these are two types of moments: clockwise moment, and other one is called anti-clockwise moment. Unit of moment of force is Newton meter, represented by Nm, where N for Newton and M for meter. And Newton is the unit of applied force, and meter is the unit of moment R. Now, what is principle of moments? Principle of moments क्या है? So with the help of this principle moments, we can understand how an object remains in balanced position under the action of number of moments. So according to principle of moments, an object is said to be in balanced position if sum of clockwise moments is equal to sum of anti-clockwise moments. कि अगर एक ही ऑब्जेक्ट पर नंबर ऑफ मोमेंट ऑफ फोर्सेस एक्ट हो रहे हैं तो उनका सम सेम होना चाहिए. सम ऑफ क्लॉकवाइज मोमेंट्स, सम ऑफ एंटी क्लॉकवाइज मोमेंट्स, they must be equal to each other. In other words, we can say that the total moment of force should be equal to zero. Again, by considering the same example where two forces are present, 300 Newton and 450 Newton, and they are producing opposite moment of force. 300 Newton producing clockwise moment and 450 Newton is producing anti-clockwise moment. And the position of both girl and boy from the axis of rotation is also given. Girl is sitting at 1.5 meter away from the axis of rotation, whereas boy is present at 1 meter from the axis of rotation. So clockwise moment should be equal to anti-clockwise moment. According to principle of moments, then this beam remains in the balanced position or equilibrium position. So in this case, clockwise moment is equal to anti-clockwise moment, where clockwise moment is producing by the force 300 Newton with moment arm 1.5. Here 1.5 is the moment arm for 300 Newton force, and 1 meter is the moment arm for 450 Newton force, which is producing anti-clockwise moments. So here 300 force and 1.5 meter is moment arm. So this product should be equal to the product of 450 into 1. Finally, 450 Newton meter becomes equal to 450 Newton meter. So this beam remains in the balanced position or equilibrium position. So this is the topic, moment of force, its factors, and the principle of moments. So with the help of this principle of moments, we can determine either of the forces if one of them is missing. Suppose if 300 Newton force is not given and the 450 and these moment arms are given. So with the help of this principle of moments, we can determine the unknown force. Similarly, we can also determine the moment arm. Thank you.